Welcome to week 2, real-time operating system and system calls. Objective of this week is to learn about real-time OS, system calls, types of CPU, design and implementation, system programs. What is real-time operating system? It responds to input immediately. Here is a task completed within a specific time delay. In real life situation like controlling traffic signals or a nuclear reactor or an aircraft, the OS has to respond quickly. What a real-time operating system is not. Real-time computing is equivalent to fast computing. Real-time systems operate in static environment. Real-time programming involves assembly coding, priority, interrupt programming, writing device drivers. There are three types of RTOS: hard RTOS, soft RTOS, firm RTOS. What is hard RTOS? These operating systems guarantee that critical tasks are completed within a range of time. For example, a robot is hired to build a car body. If the robot welds too early or too late, the car cannot be sold. So it is a hard real-time system that requires complete car welding by the robot hardly on time. Scientific experiments, medical imaging system, industrial control system, weapon system, robots, air traffic control system, etc. So real-time computer system, the operator man-machine interface. So real-time computer system interact with a controlled object using instrumentation interface. What is soft RTOS? This operating system provides some relaxation in time limit. For example, multimedia system, digital audio system, and so on. Explicit programmer defined and controlled processor encountered in real-time system. A separate process is changed by handling a single external event. The process is activated upon the occurrence of a related event signaled by an interrupt. Firm RTOS. RTOS of this type has to follow deadline as well. In spite of its small impact, missing a deadline can have unintended consequences, including a reduction in the quality of the product. For example, multimedia applications. Let's examine our learnings. Which of the following statement is true for a real-time operating system? Response to the input immediately, response to the processor immediately, response to the input will be delay. Processor respond will be delay. Which is true? The answer is response to the input immediately. Second question, which of the following is not a type of RTOS? Hard RTOS, soft RTOS, firm RTOS, fast RTOS. The odd one is fast RTOS. That is not the type. Now we will be discussing about the type of CPU. Single core CPU, dual core CPU, quad core CPU, hexa core CPU, octa core CPU, deca core CPU. What is single core CPU? In this type of CPU was used in early versions of computers. Only one core is available. This CPU will slow because if the user loads more than one application at the time, the core cannot process the new one. Therefore, major drawback was it was not capable of multitasking. With a single core CPU, only one task can be performed at a time. That's a drawback. Dual core CPU, here we have two cores. Each core is responsible for the execution of instructions. Both will execute. One core will execute one process, another core will execute another process. So the core can handle execution of two operations simultaneously, thereby overcoming the drawback of single core CPU. Quad core CPU. This CPU has 4 cores. 4 cores doesn't mean that the speed is increased by 4 times. It means that execution becomes more enhanced. It has the ability to execute multiple tasks with enhanced speed. For example, if the user has opened 4 applications, the CPU loads all the applications and simultaneously executes them. 4 core processors. Hexa, it means R, 6. This CPU has 6 cores. They can execute the task with much more speed and efficiency. The clock speed is much more as compared to the previous. The CPU is capable for ideal tasks like video editing, scientific simultaneous gaming without lagging. Example, hexa-core CPU is Intel Core i3. i3 is hexa-core. Octa-core, 8 cores. CPU with 8 cores. Basically comprise 2 quad cores, 2 4 cores. This CPU is capable of advanced task. The speed is another level and it is also known as dual core processor. It can handle multiple threads jobs efficiently. The next one is deca-core. The CPU with the 10 cores. This is the most fastest CPU capable of doing multiple tasks and parallel computing at an advanced level. Each core has capability to perform tasks simultaneously. This core is also implemented in smartphones for enhanced video editing, gaming, as the CPU does not cause the device to lag. Let's examine our understanding. How many cores will be there in hexa-core CPU? Hexa means 6. The second question, in which of the following CPU multitasking is not possible? Definitely single core. Multitasking is not possible in single core CPU. The next topic that we are going to discuss is system call. What is system call? System call is a method or a function for a computer program to request a service from kernel of the operating system on which it is running. System call is a method of interacting with the operating system via programs. System call is a request from computer software to an operating system's kernel. The application program interface connects the operating system functions to user programs. What are the features of system calls? Interface. System call acts as an interface between the user and the kernel. Production. System calls are used to access privileged operations. Kernel mode. When a system call is made, the program is temporarily switched from user mode to kernel mode. And context switching. A system call requires context switch, that is switching kernel mode and user mode. Error handling. System call can return error codes to indicate the problem and requested services. Synchronization. System call can be used to synchronize access to shared resources. System call with function calls. We already know about function calls, or library functions, or system call and function call. What is the difference? System call is a call to a subroutine built in the system, which a function call is a call to subroutine within the program. Are you able to understand? So system call is a subroutine built in the system, whereas function call is a call to subroutine within the program. Unlike function calls, system calls are used when the program needs to perform some task which does not have privilege. System calls are entry points to the operating system kernel and are not linked to the programs. Unlike system call, functions calls are portable. Time overhead of system call is more than the overhead for a function call because a transition between the user mode and kernel mode must take place. System calls are executed in kernel address space, while functions calls are executed user address space. There are many types of system calls we have. Systems calls are classified into the following categories: process control system call, file management system call, device manipulation system call, information maintenance system call, communication system call, production system calls. We will discuss about each and every category one by one. The first one is process control system call. The system call used to control the processes. These type of system calls deal with the process creation, process termination, process allocation, process deallocation, and so on. For example, fork is a system call. The fork creates a new process called a child by duplicating the current process. So this system call made when a process makes a copy of itself and the parent process is halted temporarily until the child process finishes its execution most of the time, not always. EXEC is execute is another system call. This system call used to load a new program in the current process and replace the current running process with a new process. All the data such as stack, register, heap, memory, everything is replaced by the new process, and the new process is known as overlay. Why we call it as overlay? Because the new program overlay or overload the executing process. It stops the executing process and it overload, then the new process gets executed. Process control. The next system call is wait. The primary purpose of this call to ensure the parent to wait for the child to complete its operations. This call is made when one or more child processes are forked. Suppose if you have more than one child process, if you want to make a particular child process to wait for the parent, or but if you want to organize the child process in some order, we can make it using wait function. Next is exit system call. It simply terminate the current process. Terminate the current process properly. Kill. Kill is a system call to terminate forcibly, voluntarily. It force quit. This system call most of the time used when the system is hanged, when there is a deadlock occur in the system. We kill the process and we release the deadlock situation. The second type of system call is file management. These system calls are made while working with files in OS. File manipulation operations such as creation, deletion, termination, etc. Open system call opens a file for reading or writing. A file could be any type like text or audio file, anything. Read system call reads the data from the file just after the file is opened through open system call. Then if some process wants to read the data, then it makes read system call. Write data to a file. Whenever the user wants to write into a file, we use write system call. Close is to close the open file. Seek system call is to seek the location of a system call. Location of a file. It moves the file pointer to a particular location. This call is typically made when the user tries to read the data from a particular position. For example, if you want to read from line 12, we can use the seek system call. The third category of system call is device management. These system calls are used to interact with the various peripheral devices attached to the PC, or even the management of the current device. Set console mode, write console, read console, open, close. These are various device management. What is the purpose of set console module? This system call made to set the mode of the console, that is input output, allows the process to control various console modes. Write system call allows to write data onto the console screen. Read console, read the data from the console screen. Open call is made whenever the device is opened. We want to open then we use this open system call. If you want to close the device, we use the close system call. The next type of system call is information maintenance. System call for information maintenance moves the data from the user program to the OS. Considering these services provided by the system calls are acquire the system time date, get system related information, configuration of the system, get the characteristics of the OS process, set the characteristics of OS process, get the characters, set the characters, get the system related information, acquire the system date and time or system date and time. Last, the system call type of system call is communication system calls. System call also facilitate the system's network connection. The services that they offer are open a fresh communication connection to send the data. After the transmission is finished, disconnect from the connection. On a particular connection, send a message, obtain communication from a specific connection. Identify and connect a specific remote device to the network. Remove a specific remote computer. When two or more processes are required to communicate, then various inter-process communication mechanisms are used by the OS, which involves making numerous system calls. So communication means if two process or two system wants to communicate, then system calls are used. For example, in Java or some operating system, to communicate between the system, client and server, socket, system calls will be used. To make a communication between the process in a single system, inter-process communication tools like Piper, FIFO and so on will be used. So this is the communication type of system calls. So first it creates the communication, then it creates the communication, then establish the communication, then perform the communication. Some of the inter-process communication tools are pipe creates unidirectional communication. Socket creates network communication. SHM get, that is semaphore shared memory creation. It creates a shared memory to allow two processes to communicate. SIMGET create the semaphore for process synchronization. MSG get, that is create message queue to communicate, to make a communication between the processes. These are all semaphore, SHM get, SEM-GET, MSG get are system 5 inter-process communication tool. Pipe is also a IPC. Socket is not IPC, that is for communicating between client and server. Production. The next type of system call. Production provides mechanism for controlling user or process have access to which resources. System call allow the access mechanism to be adjusted as needed, and for non-privileged users to be granted elevated access permissions under carefully controlled temporary circumstances. Only one of the concern on multi-user system. Production is now important on all systems in the age of ubiquitous network connectivity. Example of Windows and Unix systems calls. So here see process control. In Windows, create process, exit process, wait for a single object. These are the process control system calls in Windows. Whereas in Unix, for exit and wait. File manipulation. Create file, read file, write file, close handle. These are all Windows system call for file manipulation. The same thing in Linux, open file, read file, write file and close file. Open, close, read, write. Open, close, read, write. These are the Unix system calls for file manipulation. And then device manipulation. Set console mode, read console, write console and so on. For Windows. For Unix, IOCTL means input output control, and read the data from the device, and then write the data into the device. Device means input device or output device. For example, monitor, if you want to write into the monitor, this write system call is used to send the data to the monitor. System call example. So we can see a system how we copy one program to another program. For example, we have to open the first program, first file. Then we open the second file, whether the file is exist or not. If the second file is exist, we say error, and then we asking whether to overwrite yes or no. If say yes, then we'll continue. We read the data from the source file, and we write the read data from the source to destination. Then we continue the step 4 and 5 until the source file is empty. Now this is the open system call. Open system call has two arguments, path and flag. The path is the file where we want to open, and flag is the mode of opening. The flag is the mode of opening. For example, O read only means open the file for read only, open the file for write only, open the file for read and write, create the file, create. O exclusive means prevent creation if it already exists. O append is for appending a file for adding the data. Second system call is close system call to close the open file, that is the file descriptor is the only argument. Third system call read the file. Three arguments here. The first argument is the file descriptor, which is the number when we open the file. The second one is the value to write into the read from the, that is buffer read from the source. And third is the size of the data. And the third system call is write. The syntax for write is very similar to read. The only thing is second argument for read means the read data will be stored into the buffer. Here in write, the content of buffer, the second argument will be written to the disk, written to the file. That's the only difference. This is a program you see here. First we open the source file. Argument 1 means the value, the name of the file passed through command line arguments. We first open the first file, source file. Second file we open in O exclusive. It means if it already exists, it won't create again. Okay. Then file descriptor 2 is equal to -1. It means the second file is already exist. If so, we are asking whether to override yes or no. If the user says yes, then we continue. If the user says no, we exit. If the user says yes means what? We open the second file for a writing purpose. So first file we open for reading purpose here. Second file we open for writing purpose. Suppose the second file exists, we are asking whether to override yes or no. If the user says yes, then only we open the file for writing. Now the while loop read the source file and write into the destination file. That's all. Let us check the understanding. System call EXEC belongs to which category? File management, process management control, device management, or memory management? EXEC belongs to process control. Second question, which of the following system call is used to create a process? Fork is a system call to create the process. Design, codes and implementation. We have some design codes when we implement the OS. The design codes are the objective of operating systems. These are some design codes: concurrent systems, security and privacy, resource sharing, flexible to accommodate the changes, portable operating system, backward compatibility. There are two types of system codes: user code and system codes. User code easy to use. Specifications are not very useful as it is no set method to achieve this code. System code, operating system be easy to design, implement and maintain. Easy to design, implement and maintain. That is a major important system code. User code means easy to use, convenient to use. That's all. Mechanism and policies. Policies may change over time, whereas mechanism, that is few changes even when the policy change occurs. For example, if a mechanism and a policy are independent, then few changes are required in mechanism if policy changes. Mechanism shows how to do something and policy shows what to do. Policy means what to do, mechanism means how to do. Examine our understanding. Which of the following is described as user goal for OS design? The answer is easy to use. User goal is easy to use. Which of the following statement is true? Mechanism shows how to do. Policy shows how to do. Mechanism shows what to do. Policy may not change over time. Mechanism shows how to do. Policy shows what to do. So that statement is not there. So B and C is not correct. So the answer is definitely A. Mechanism shows how to do. What is system programs? System programs are special software which gives us facility to manage and control the computer, hardware and system. For example, MS Word processor system programs. It is used to perform editing operations. So system programs act as an interface between the operating system and system program actually works above operating system layer. Types of system programs are Unity program, device driver, directory report tools, file management, status information, programming languages, compiler, assembler, and so on. Programming, loading and execution, communication, background services. So these are various system programs. We know there are many system programs, editing programs, Java languages are system programs, compilers are system programs. So system calls requires a service from the kernel, whereas system program offers an environment for the program to create and run. So system calls low level request to the user program, system programs higher level request. Programming language, system calls are usually written in C, C++ language, whereas system programs can be written in higher level languages, other languages. User point of view, it defines interface between the service and the user. System call. System program user interface of the OS. So the user process requires OS services using a system call. It transfers the user request to a set of system calls needed to fulfill the requirement. These are the classification of system call. These are the categories of system programs. Examine our learning. System program perform essential operations which can be performed by application software. System programs are commonly written in higher level languages. In this week, we learned about real-time operating system, system calls, types of CPU, design and implementation of OS, and system programs. Thank you.